For lesson 1.6, we are going to be learning about literal equations. So let's talk about what are literal equations. The boxes at the right give examples and non-examples of literal equations. Based on your observations, what do you think makes something a literal equation? So let's look at these examples. Y equals mx plus b, a equals bh, c plus 5 over d equals 12. Those are examples of literal equations. And non-examples are g minus 11 over 3 equals 20, 196 equals 8w, 3.5x minus 4 equals 10. So what's the main difference between the examples and the non-examples? Well, you'll notice all of the examples have two or more variables, and the non-examples only have one variable. So that is what a literal equation is. Literal equations have more than one variable. Okay, all the examples have more than one variable. Some of them have 3, some of them had 2, some of them had 4, but they all have more than one variable. So a literal equation has more than one variable and can be rearranged to solve for a specific variable. So what that means is like this right here, A equals BH. This is area equals base times height. Well, a lot of times when you're younger, they're going to give you the base and height, and you're going to use that to find the area. But as you get older, they may give you the base and the area, and you're going to solve to find the height. So that's where you will be able to rearrange and solve for whatever variable is missing. Okay, all right. So what are great examples of literal equations? Well, those are formulas. All the formulas you've learned for perimeter and area and volume and surface area, those are great examples of literal equations. So we want to list at least 3. Now there are a bunch that you could list. So I'm just going to talk about 3 and then maybe you can think about some other ones. So I already talked about area. So we're going to say area equals base times height. This is how you find the area of a rectangle. Okay, area equals base times height. Okay, all right, another one that you learned in 8th grade would be like a squared plus b squared equals c squared. Okay, that is another formula that you should be familiar with. And then let's do like a perimeter. How about a perimeter of a rectangle? Okay, perimeter equals, there's a couple ways you could do this, but we're going to say you have 2 lengths that are identical plus 2 widths that are also identical. You can combine the lengths and the widths together to get the perimeter. Okay, so notice all 3 of these examples have more than one variable. Okay, so here down below we have 6 examples, and we're going to show you that you're going to solve a literal equation exactly like the equations that you've already been taught how to solve. So we're going to pick a specific variable to isolate, and we're going to use all the opposite operation to isolate whatever variable they are requesting. So we're first going to solve the left one, and then we're going to use similar steps to solve the literal equation that's here on the right. So here we go. We have 144 equals 4b. So I'm going to draw my line. This is going to require me to divide both sides by 4. And when I divide both sides by 4, I get b equals 36. Now, you can leave this as 36 equals b, or you can put the b on the left side, which is how you're going to see it most often. B equals 36. Okay, so with that being said, let's look right next to it. And they want us to solve for f. So I'm going to keep the f right where it is. So the e is in front of the f. They're being multiplied. So the e needs to move to the opposite side. Okay, well, we're going to refer to over here. See how 4 was in front of the b coefficient, and we divided both sides by 4. So we're going to keep that same pattern, but we're going to divide by e. Divide the left side by e. Okay, bring down my equal sign. Well, on the right side, e divided by e. Anything divided by itself cancels out to be a 1. So we have f equals, now d and e are not like terms, so we're not actually going to have to do any division. It's just going to be d over e. That's the best thing about literal equations, is most of the time you don't even have to add, subtract, multiply, and divide. You're just going to move the variables around using opposite operation. So again, we are solving for f, so we prefer to put the f first. So f equals d over e, or d divided by e. All right, b. Let me draw my line here. I'm going to isolate the only variable, so I need to isolate x. I'm going to begin by subtracting 9 on both sides. When you subtract 9, you end up with 13x equals 91. And so we subtracted on both sides. Now we're going to divide both sides by 13. When you divide by 13, you end up with x equals 7. 91 divided by 13 is 7. So this was a two-step. We first subtracted both sides, then we divided both sides. Okay, so let's look at the literal equation. It wants us to solve for m. We're going to isolate m, so the m needs to stay put exactly where it is. Okay, so let's draw our line. Okay, so the first step over here on the left was subtract 9 on both sides. So what do we think we're going to do over here? We're going to subtract b on both sides. Okay, we're going to bring down the mx, just like we took the 13x and brought it straight down. We're going to bring down our mx. B minus b will cancel out. Bring down the equals. And then y and b are not like terms, so we're just going to keep them separate. We don't actually have to do any subtraction. We just write y minus b. Okay, then the second step over here was divide by 13. So what do we want to divide by? Remember, we're keeping the m where it is. We're going to isolate m, so keep it there. So we're actually going to divide by x. And if I divide the left side by x, I have to divide the entire right side by x as well. Okay, so any number divided by itself is going to cancel out, and you're left with m equals, okay, y, b, and x. Are any of those like terms? They are not. So we're going to keep them all separate, and we get m equals y minus b over x. Okay, let's move down to the second row here. We have 360 equals 5 times 12 times 8. All right. So we have a little simplification we can do here first. We can do the 5 times 12 first and make that 60, or we can go ahead and start dividing it over. This is all multiplication. So I know that I'm going to have to divide by 5 on both sides, and I'm going to divide by 12 on both sides. So I've kind of combined two steps into one. So I'm going to reduce the 5's reduced to 1, the 12's reduced to 1, and I'm only left with 8. And then I'm going to do 360 divided by 5 times 12. Well, 5 times 12 is 60. So when you divide 360 by 60, you get 6. So let's apply those same steps here to the literal equation. So the equation is asking us to isolate H. So here's H. I'm going to keep H exactly where it is. Okay? I'm not going to move it. I want to keep it right there. So this was one step. It required me to divide both sides by 5 and 12. So over here, what are we going to divide by? L. I like to write my L's cursive because I don't want it to look like a 1. And W. When I divide the right side by LW, I'm going to divide the left side by LW. And on the right side of the equal sign, my L and W are going to cancel out. That means that H has been isolated. And then on the left side, I don't have any variables that are like terms, so I'm just going to put V divided by LW. So this is a volume formula. Volume equals length times width times height. You've heard that before. And they always gave you the length, the width, and the height. But now we're going to advance into more algebra where they're going to be missing the height and you have to find it. Here's how you would go about finding that. Okay, all right, D. Let's go ahead and draw our line down our equal sign. I have some PEMDAS here. Okay, 2 times 7 is 14. So I have 70 equals 14 plus 2n. I need to move my constant across to the other side by subtracting 14. When I subtract 14 here, I'm going to end up with 56 equals 14 minus 14 cancels out to 0, 2n. And then I need to divide both sides by 2. Keep that line going down. So 56 divided by 2 is going to give me 28. And 2 divided by 2 is 1. So I get n equals 28. Okay, let's see if we can do those same steps over here. So the first thing I did was multiply 2 times 7 to get 14. Can I do anything with m times j, or is it just going to stay m times j? Okay, we're just going to keep it. The second step was subtract 14 on both sides. So over here, what are we going to subtract on both sides? The mj. H is not the same variable as mj, so I need to keep these separate. I'm going to have to squeeze this in because of the way I drew my line, but I'm going to do H minus mj equals, bring down the 2k. All right, then the last step over here was divide by 2. So if we divide the right side by 2, we have to divide all of the left side by 2. 2 divided by 2 cancels out to be 1. And H minus mj divided by 2. Okay, we can't do anything there because we have too many variables and we can't combine them. So k equals H minus mj all over 2. Okay, let's look at it. We have our last two examples here. This is 75 equals x over 2. And remember that line means divide. So we're going to draw our line. What is the opposite of divide by 2? That will be to multiply by 2. And to keep it balanced, if we multiply the right side by 2, we must also multiply the left side by 2. So our 2 in the numerator and denominator on the right side will cancel out. You're left with x equals 2 times 75 is 150. All right, so here we go. They're wanting us to isolate Q. So I'm going to leave that Q exactly where it is. It's Q divided by R. So how do I move R across to the other side? I need to multiply both sides by R. So on the right side, the R's reduce, and all I'm left with is Q. and the left side is r times t. And I don't know what those values are, so they just go side by side, rt. When they're side by side, that means they're being multiplied. All right, last example, 144 plus c squared equals 169. So let's draw our 9. We only have a c that we're going to have to isolate. So we're going to begin by moving the positive 144 across by subtracting 144 on both sides of the equal sign. When you do that, we have c squared equals 25. Okay, here's a new one we haven't done yet. You did this in junior high when you did the a squared, b squared, c squared. Okay, but we haven't had one yet. So we're going to have to undo the squared. So the opposite of squared is square root. Okay, so we're going to square root both sides of the equal sign. Okay, all right, when you do that, they're basically asking you what two numbers can you multiply to be 25. What times what is 25? Okay, so you guys are well aware that 5 times 5 is 25, but can you think of another one that's 25? What about negative 5 times negative 5? Negative times a negative is positive, and 5 times 5 is 25. So in the scenario where you're taking the square root, you can actually get two answers, a positive or a negative 5. This symbol, plus or minus, we will work more in detail with in the spring, but that's just an introduction right there. Positive or negative 5, there's two different answers when you take the square root of 25. All right, so let's apply this to the literal equations. They are asking us to solve for x. So I want that x to stay put right where it is. So first step was subtracting. So what am I going to subtract over to the right side? Minus y squared. I'm going to bring down the x squared. Y squared minus y squared cancels out to be 0. And z squared minus y squared are not like terms, so I just need to keep them separate. You will notice I put a line through my z because I don't want to look at it and think maybe it's a 2. So I put that line through so I don't confuse myself that that is a z. Okay, so we've done the subtraction. What was the next line? How did we change c squared to be just c? Well, the opposite of squared is square root. So we're going to square root the left side and we're going to square root the right side. And we just talked about every time you take the square root of both sides, you're going to have two solutions. You need to have a positive and a negative. That's what we call a plus minus. Okay. Can we actually take the square root of these? We cannot. And again, we will talk more about this in the spring. So we're going to leave this as the square root of z squared plus y squared. Oh, that's not plus y squared. Hey, why didn't you say something to me? What should that be? Minus y squared. Looky there, z squared minus y squared. So this should actually be a minus. I'm glad y'all were paying attention. Okay, that is going to be z squared minus y squared. So let me rewrite that down here. X equals plus minus square root of z squared minus y squared. See, we all make mistakes. So make sure you're paying attention and cooperatively work with each other. Talk it out so you can make sure you can find those errors that we make sometimes. Okay? All right. Good luck on literal equations.